This is Note-Taking Guide 6.5 for Mathematical Decision Making for Life. Today we're going to talk about the difference between a population and a sample. So let's just kind of get started on what those actually are. So the definition for population is an entire group of individuals that we want information from. As compared to a sample, who is part of the population that we actually examine in order to gather information. So population is an entire group, sample is a piece of that group. Okay, a couple more vocabulary words. The next vocabulary word is called a sampling. And a sampling involves studying a part in order to gain information about the whole. So again, taking a sample of the entire population. And then the next one is census. A census attempts to contact every individual in the entire population. So this is the year 2020 right now while I'm making this video, and this year is a U.S. Census year, which means the United States government sends out a questionnaire to every household in the entire nation. They are trying to get an accurate and exact count of how many people are in the United States. They do this every 10 years. So again, it's a census. It's an attempt to count every individual in the entire population. Now, that's the U.S. Census. A census could be in a smaller group. Say you wanted to know how many kids in the school liked hot dogs. Well, in order for it to be a census, you would have to make sure that you included every kid in the school in that study that you are doing. So census is an entire group or of people, a population. Okay, let's go through and see if we can answer these questions. So it says, use the scenario to answer the questions. A beverage company wants to see if people in the United States like their new logo. Which choice best represents a population? Now, a population, again, if you remember, is the entire group of individuals. So it says here, we want to see if people in the United States like their new logo. So we're looking for the population of everybody in the United States. So when we read these answers, let's see which one fits that the best. So A, a selection of logo artists. B, every person in the United States. C, a selection of shoppers from different states, and D, 3,800 children ages 5 to 15. Well, as it read in the question, the population would actually be every person in the United States, which is part B here for my answer. Okay, so let's go and look at the next example. Use this scenario to answer the question. A musician wanted to see what people bought his last album. What they thought about their songs. Which choice best represents a sample? So now if you remember, a sample is a piece of the people or a group of the people or of the population. So the population in this case would be everybody who bought his album. So now we're looking for the best one that represents a sample. So A says every person who bought his album. That's not the sample, that's the population. So we don't want that one. B, a selection of people who did not buy his album. Well, that's not even in the group that we're looking at, so that's definitely not going to be it. C, 250 girls who bought the album. Now, that is a sample of the population, so let's see if D is a better answer. D, a selection of 3,294 people who bought the album. Well, D is definitely a better sample of the people who bought his album because in C, it only counts 250 girls. And D is 3,294 people who bought the album. So D is the better example of what a sample of that population is. All right, couple more vocabulary words here. The next one is a parameter. A parameter is a number that describes the population. So a parameter is a fixed number, but in practice, we don't usually know its value. So for again, an example, if we were talking about that U.S. Census that is being done this year in the year 2020, right now, I couldn't tell you the exact number of people in the United States, but we know that they're countable. We know that number is there and available to us, but we probably don't know its value exactly right at this minute. That kind of a number is a parameter. A statistics, on the other hand, is a number that describes a sample. The value of a statistic is known when we have taken a sample, but it can change from sample to sample. We often use a statistic to estimate an unknown parameter or population. So if we, for instance, talking about the U.S. Census again, if we said, oh, well, what about the people in California? Do we know how many people are in California? Well, that number, the number of people in California, would be called a statistic because it is the number that represents a sample of the entire population. So that's kind of what a statistic is. All right, so here's an example. It says, identify the parameter and the statistic in the following research study. A marketing manager tested the claim that more than 55% of children aged 8 to 12 have cell phones. In a survey of 802 children aged 8 to 12, about 56% had cell phones. So it says, describe the parameter and describe the statistic. Now again, parameter comes from the entire population. Now, I'm not sure that we know the entire population, which is what a parameter is. It's a number that we know exists, but we don't usually have the value for. So if I'm going to describe the population, I'm going to say it's 8 to 12-year-olds. And then maybe to even be more specific, I would say the number of 8 to 12-year-olds, because we know that we're looking for a number there, but we don't know the actual value here. But the statistic, on the other hand, the statistic comes from the population, the sample of the population. The sample of the population is 802 children that were surveyed, and 56% of them had cell phones. So of the entire sample of 802, we can then find the statistic. The statistic would be 56% of the 802. And 56% of the 802, when you plug that in your calculator, you get 449.12 for that number. So that would actually be the statistic, the actual number that you can find from the sample of the population. Okay, this next problem right here, there's actually a lot of statistics behind this problem. I'm not going to teach you a ton of the statistics around here. I'm just going to show you kind of a formula to use. The reason I'm going to do that is we really only have one homework assignment problem that is like this problem. So I'm kind of just going to show you some stuff to be able to do it, and then we'll get into this a little bit deeper on another day. So before we even get started though, on this part right here, we kind of need to know something called a z-score. And I didn't include what a z-score was or the chart of z-scores here. So I'm going to give you a part of a chart here to look at z-scores. And they're done by intervals of confidence. So a 93% interval of confidence would have a z-score of 1.81. And then a 95% confidence interval would have a z-score of 1.96. And then we're just going to do one more in our chart here. Let's do a 98% confidence interval, and that z-score would be 2.33. You guys, where did I get these from? I actually looked them up on the internet for z-scores. What these z-scores are is, if you remember when we looked at that curve of that bell curve, that standard deviation curve that we are going to look at even more in the next couple of days here. We've talked about this bell curve a little bit, but what that z-score is it tells how far away you are from the mean, from the middle, and the interval in which we're in. But again, like I said, a lot of statistics in this, so we're not going to go over a ton of these statistics. We're just going to kind of show you the formula that we need in order to do this problem. So it says, find the confidence interval from the margin of error. A poll of 3,400 adults were asked if they had rode a roller coaster. 62% said yes, at a 93% confidence level. Find the margin of error and the confidence intervals. So what we're going to do here, we have three numbers here that seem to be important to us. What we're going to do is we're going to follow a little bit of a formula that's for our margin of error. So the margin of error formula we're going to do, and it said that our confidence interval was 93%. So our margin of error formula for 93% confidence, what we're going to do here on this is we're first going to take our z-score. So our z-score for 93%, which is 1.18, I said that wrong, but I wrote it right, 1.81. We're going to take that and we're going to times that by the square root of a couple of numbers. Now, if you remember when we did the margin of error the other day, we did 1 over the square root of n. That's kind of where this number is coming from, the square root part of the formula that we're using here. But we're going to use some different numbers here. So I'm kind of running out of space to draw in over here, but let's see if I can fit it in. And actually, maybe I'll just come down over here and rewrite it. So I have 1.81, and then I'm going to times it by the square root. Inside the square root, I'm going to put the percent that we are talking about that said yes. So 62%. I'm going to put it as a 0.62 though. And then I'm going to times that by, I'm going to take that 0.62 and subtract it from 1. So 1 minus 0.62 is 0.38. So I'm going to times that by the 0.38 over top of the total number of people that we surveyed. So 3,400. And then this is really just a calculator problem. So again, just to remind you what we did here, was we took our z-score, which was the 1.81, we times it by the square root of our percent that was in our problem, 62%, times, and then this 38% right here, it's because 62 and 38% add up to be 1%, and then divided by the 3,400. So you're going to put that in your calculator exactly the way that I just did right there. And when you do that, it's going to give you the answer of 0.015. And then move your decimal point 2 places to get your percent. So 1.5%. And then that is how we're going to do it. So again, make sure that when you do, there's one problem like this on your assignment. Make sure when you do this, you come and grab your z-score off of here. I made sure that today I gave you the right z-score for the percent that you're going to have to do on your problem. And then your percent in your problem of the people who answered, the 62%, is the first number underneath the square root right here. And then subtract it from 1 to get the second number, and then put this number over the top of the total people that we sampled. And then you'll get that confidence interval. That 1.5% is our confidence interval. So anyways, good luck on your homework. Let me know if you have any questions.